Welcome to this deep dive.
Tech Twitter is completely panicking right now. People claim Anthropic burns $5,000 a month just to run a single user's coding AI.
That tension is our narrative through line today. We are unpacking the hidden mechanics of AI scaling. We will start with the real cost of AI, then look at the chaos of deploying it.
From Google to Amazon.
Right. Then we explore tools empowering the edge. Finally, we end with a massive architectural breakthrough, a shift in how AI speaks to you.
We really have to start with the math. Let us unpack this $5,000 myth.
Where did this even come from?
It traces back to a viral Forbes article. It was about a popular coding tool called Cursor. They looked at Anthropic's $200 Claude plan, and they guessed it burns $5,000 in compute.
That sounds absolutely terrifying. For any sustainable business, that is a death sentence.
It sounds catastrophic. But you have to look at the API pricing. Specifically for the Claude Opus 4.6 model, it costs $5 per million input tokens and $25 per million output tokens.
Just to clarify for everyone, tokens are the basic building blocks of text for AI.
Exactly. So if an extreme power user goes crazy, the API usage could theoretically hit $5,000.
But that is retail pricing.
Right, and that is the crucial distinction everyone misses. API pricing is absolutely not raw compute cost.
It is like looking at a restaurant's menu prices and assuming that's what the ingredients cost the chef. You have to factor in the massive markup.
You really do. We can look at open platforms instead, like OpenRouter for a much better baseline.
Yeah, they host open source models.
Right, like Quinn 3.5.
Yeah.
The massive 397 billion parameter version.
Yeah.
Or Kimi K2.5.
How do their costs compare?
They are roughly 10 times cheaper than Anthropic.
Right.
Raw compute is maybe 10% of the sticker price.
Wow. So the true cost is much lower. It's closer to $500 a month.
At an absolute maximum, yes.
Yeah.
And those power users are incredibly rare. Fewer than 5% ever hit those limits. Most pay between $20 and $200 monthly. It easily makes the system break even, or even highly profitable.
Could those extreme power users still bankrupt a smaller startup before they scale?
Maybe very early on. But smart caching usually solves that problem immediately.
So raw compute is just a fraction of the sticker price.
Exactly. Which brings us to the friction of reality. Because inference is viable, we are seeing rapid integrations.
So compute is not the bottleneck. Why are systems breaking so spectacularly in the wild?
It really comes down to deployment desperation.
Yeah.
OpenAI plans to integrate Sora directly into ChatGPT.
The video generation tool.
Yeah, and Google put Gemini inside Workspace apps.
Right. Google Docs writes for you. Sheets uses live web data. Slides makes full decks.
They also launched Gemini Embedding 2 in public preview. It is highly multimodal.
Meaning understanding text, images, and audio all at once.
Exactly. We're also seeing this in regulated fields. There's an AI legal startup called Legora. They just raised $550 million. They hit a $5 billion valuation.
That is massive.
And they're already used by 800 law firms. It is a Claude-powered system.
What about the physical hardware side of this?
Meta just unveiled 4 in-house AI chips. They're rolling out updates every 6 months.
Wait, I have to push back on that timeline. Hardware is notoriously hard to pivot. Why attempt a 6-month cycle?
To reduce their heavy reliance on NVIDIA GPUs, they are optimizing for pure speed over perfect efficiency.
But fast deployment means things inevitably break.
Oh, absolutely. Amazon triggered multiple incidents recently. They're using autonomous AI coding tools.
Yeah, I read about that. One AI actually deleted a live production environment. I still wrestle with prompt drift myself, so an AI deleting an environment is terrifying. It perfectly highlights the danger of unmonitored autonomy. And it is not just broken code causing chaos.
Right, the legal friction.
A U.S. court just ordered Perplexity to destroy data. Their Comet browser accessed Amazon data without permission. Fast deployment means breaking things, both code and laws.
That is the grim reality of the current landscape. But away from the tech giants, things are different. Specialized tools are quietly changing how individual developers work.
Empowering the edge.
Exactly. Have you seen InsForge yet?
I have not.
It deploys full-stack apps just by saying the word. You can deploy to their cloud or your domain.
Wow. No manual configuration at all.
None. And then there's a tool called Cardboard. It is an agentic video editor.
How does that work exactly?
It moves raw footage to a final cut. It actually understands the semantic contents of your clips. Then you have personal agents like Interact. It is an AI reputation coach.
For social media?
Yeah, for LinkedIn, X, and Reddit. It learns your unique voice over time.
The UI shifts are the most interesting to me. I was looking at OpenUI recently.
Oh, that one's fascinating.
It makes AI apps respond with interactive components, cards, dynamic tables, and forms, instead of just static text.
Right. It completely changes the experience.
Yeah. It is like stacking Lego blocks of data, instead of reading a wall of text.
It makes the AI feel like a true software partner.
Are tools like Cardboard and InSforge replacing human taste? Or just the tedious manual labor?
Mostly just the tedious manual labor.
Yeah.
You still desperately need human taste to curate things.
We're moving from text chats to instant software creation.
It is a massive structural shift in how we work. And speaking of shifting how we work, sponsor.
We are back. We covered the real costs and the deployment chaos.
And those specialized edge tools.
Right. But to make all these tools truly seamless, especially voice agents, we need to fix the awkward lag in AI speech.
It is a very noticeable, very weird problem. Current AI speech skips words constantly.
Or it is just far too slow.
Because it bolts two entirely different models together. One writes the text, the next generates the audio.
So what is the actual breakthrough here?
Hume AI just open-sourced a model called Tate-A. It generates text tokens and acoustic features together.
In one unified stream.
Yes. They tested it on over 1,000 complex samples. It had absolutely zero content errors.
That is practically unheard of.
And it runs at a real-time factor of 0.09.
Which measures how fast AI generates audio compared to real time.
Right. It is roughly 5 times faster than typical models.
And what about the token capacity?
It handles 2,048 tokens smoothly.
That represents about 700 seconds of continuous speech. Typical systems top out at 70 seconds. Whoa. 2-sec silence. Imagine scaling to 700 seconds of perfect speech in one go. That changes everything.
It really does. And it outputs a perfect transcript simultaneously with zero extra latency.
Where can people actually find this?
It is available right now on Hugging Face and GitHub.
What happens to human connection when AI can speak flawlessly, without that robotic hesitation?
That is the scary part. We rely on that hesitation to recognize machines. Trust will become a massive societal issue.
Generating text and sound together eliminates the awkward lag.
Exactly. So if we synthesize this entire journey, AI compute is significantly cheaper than the hype claims, which explains the massive flood of wild integrations. But the real frontier is seamless multimodal interaction, like Hume's unified speech model.
It leaves you with a deeply provocative thought. Compute is actually cheap, and open source models like Hume's Tate-A are matching closed systems.
Beating them in latency, even.
Will the future of AI be controlled by massive tech monopolies? Or will it live locally on our own devices, completely free from the cloud? Keep staying curious about these systems. Thanks for joining this deep dive. Out to your own music.